All right, AP Chem crew. In this video, I'm just going to be going over the model kit practice lab, or the practice lab quiz. So just going over the answer key, kind of explaining some certain things to watch out for, and what it's going to look like when you take the AP exam, when you take the quiz, and when you take the AP exam. So let's check that out. So we're talking about this practice quiz. So this is essentially what your quiz is going to look like. So notice, like a lot of times in AP chemistry, they ask you to draw a dot structure for something, but then they kind of give you how it's set up. So all you're doing is really filling in the bonds and all the electrons, and then answering questions about the molecule from there. Okay. So let's go through this. Again, the key's posted, but if you needed just more of an explanation. All right, so if we look at this, we're drawing the dot structure for HCOOH. So the first thing I did was just count how many electrons I need to be represented in my structure. So each hydrogen is one, carbon is four, and each oxygen has six valence electrons. So I need a total of 18 electrons, 18 dots, 18 valence electrons in my structure. I have it kind of stepped out for you later on my notes. So let me just show you what we're doing here. So the first thing to do would just be connect everything with a single bond. So I just put single bonds between all of the atoms there. And remember, I needed 18 dots, and right now in this structure I have 8 dots, so I need 10 more. Okay. So 10 more dots means 5 more lone pairs. So if I put 2 lone pairs on the oxygen here and 3 lone pairs on the oxygen here, that's a total of 5 lone pairs, or 10 electrons. So this structure has the correct number of dots right now, right? So I got, in terms of how many valence electrons need to be in the structure, I'm good. However, we got to remember carbon is a must-have 8. So we can't draw any more dots. So don't, just draw a lone pair on the carbon and call it a day, because that would end up being 20 dots. You need 18. So what do? We take a lone pair from one of the oxygens and we make it a double bond. And so that would be the final structure, and that's what I would get. Now, some of you might end up drawing the double bond here instead. That would be acceptable for this question, but it wouldn't be the best way in terms of formal charge. And also, if you just remember what a carboxylic acid kind of looks like, it's the OH functional group, which looks like this, and the double bond O functional group on the same carbon. So that might be another clue to why this is the better structure. But if you assigned formal charges, all the formal charges in this have a formal charge of 0. But here, this oxygen has a formal charge of -1, but this oxygen here has a formal charge of +1. And so that's why it's really no good. You got a positive formal charge on a more electronegative element, okay? So that would be my structure. Then it's just asking you the bond angle around the carbon atom. So be careful. They drew it like it looks like 180, but we got to go 3 domains. So the bonding angle is going to be 120, okay? It asks for the hybridization of this oxygen. So this oxygen has 3 domains around it, and so it's sp2 hybridized. If they asked about this oxygen, it would be sp3 because it has 4 domains around it. And then it asks for the geometry around this oxygen here. And so if it asks for geometry, there's 2 possible answers here. Whenever you have 4 domains, the electron geometry is called tetrahedral. And the shape depends on what those domains are, right? The bonding domains versus unshared paired domains. So you could just say bent, because that's the shape, and bent is tetrahedral geometry, or you could say tetrahedral. But I would probably say bent, because I just want to remember that's bent shape. But again, four electron pairs means tetrahedral geometry, okay? All right, number 2, we have 3 possible diagrams for the compound AlCl3. And notice this is not an ionic compound. So if you were like, well, aluminum's a metal and chlorine's a non-metal, shouldn't that make an ionic compound? Well, they're saying this is a molecular or covalent compound, and the way you know that is because they're showing covalent bonds between the aluminum and chlorine. Okay, so just roll with it. All right, it's covalent. And then so it says it tells us that the geometry should be trigonal planar, and so based on that, we can eliminate one of these diagrams. And so remember how to answer questions in AP chemistry. If they ask you a question, whether it's like yes or no, or which diagram is it, diagram 1, diagram 2, diagram 3, and then justify, answer the question and then justify. Don't start justifying and somewhere within your explanation say diagram 2, right? So the one we can eliminate in this question is this diagram 2, because diagram 2 is either, you can call it tetrahedral geometry or you could call it trigonal pyramidal geometry, right? So diagram 1 would be trigonal planar, diagram 3 is trigonal planar, but diagram 2 is trigonal pyramidal. So we can eliminate, based on the fact that it has to have this geometry, trigonal planar geometry, we can eliminate diagram 2, okay? And then it says, which of the three diagrams is the best representation for the bonding of aluminum Cl3, aluminum trichloride? Justify your choice using formal charge. So based on this one versus that one, diagram 1 has the better formal charge. If you, let's see, I think I did it in my notes here. Yeah, so in diagram 1, all the formal charges end up being 0. But in diagram 2, the aluminum ends up having a -1 formal charge, and the chlorine with the double bond ends up having a +1 formal charge. And so you can have diagrams where you have formal charges that aren't 0, but remember, if you can get all zeros, that's going to be your best one. But and then if you have any formal charge, you don't want the positive formal charge to be on the more electronegative element, and chlorine is more electronegative than aluminum. All right. So based on formal charges, diagram 1 is your best option there. Okay. All right. So we keep moving. This next one is very similar to, if I pull up the blank quiz, right? So it's asking for you to draw the dot structure of S2Cl2, but they set it up so you don't have to worry about knowing what is bonded to what. They have it set up for you. So again, just like that first one, I'm going to just draw single bonds. I think I have it in my notes here. So I'm going to draw single bonds to everything. And I count up how many dots. So sulfur comes in with 6, but you have 2 of them, so that's 12. Chlorine comes in with 7, but you have 2 of them, so that's 14. So you need a total of 26 dots. I'll start by connecting everything with single bonds only. Okay, so I got 2, 4, 6. So I need 20 more dots. Then I'm gonna, so I can add 10 more lone pairs to get my 20 dots. But kind of also understanding, right, halogens really never have, I don't want to say never, but rarely do they have double bonds or triple bonds. So the halogens usually look like this. So I'm gonna go ahead and draw the lone pairs on the chlorines as is to satisfy the octet rule for the chlorine. And then that, when I have this structure, that gives me 18 dots. I still need 8 more. So that means 4 more lone pairs. And so if I put 2 lone pairs on each of the sulfur, then boom, I got my 26 dots. I don't need to draw any double bonds or anything because the sulfur here has 8 electrons around it. The sulfur here has 8 electrons around it. The chlorines all have 8 electrons. So everyone's octet rule is satisfied. Sulfur could support more than 10, but it doesn't need to in this case. And so I'm good. That's all I needed to draw. I have the right number of dots and everything's octet rule is being satisfied. The thing is, I just got to be careful with the questions that they're asking. So let's go back. So there's my structure. I filled in the box. So it's asking the bond angle. And so again, they're trying to get you to say 180 because they drew them straight across. But I got 4 domains around my sulfur there, so I really should say 109. If you want to say 105 because it's bent, that's fine. Whenever you have 4 domains and you're asked about a bond angle, it's really this range is acceptable. So I always just tell students, if it's 4 domains, say 109. If it's 3 domains, say 120. If it's 2 domains, say 180. All right, and you're not going to be expected to know the bond angles for expanded octet molecules. Okay. All right. So if we go to number 4, okay, it gives us a dot structure for this methanamide. Okay. So you don't have to know that it's organic. You don't have to know what an amide group is or anything like that to answer the questions. It's just about the structure. So the first they asked about this bond angle, and a lot of kids are going to say 180 because that's the way they drew it, but 3 domains around the carbon there, right? So 120. And then they ask you about this bond angle. So I got 4 domains around the nitrogen, so that's why I say 109. Remember, for trigonal pyramidal shape, you could say 107, but again, 4 domains, just say 109, okay? And then in part B, this is when they, if we look at the actual quiz, this is when they give us kind of a straight up, hey, here's the molecule we want you to draw the dot structure of, but it's blank, okay? But they give us some clues. They say the carbon has the same geometry that's in this compound above. So trigonal planar geometry. So that means only 3 things bonded to it, okay? So another, thing to watch out for is this is the same exact formula as this. It's just written differently. So guess what? It's going to be the same exact structure. But understand what they gave you here. They told you that it has the same geometry. So if you wanted to kind of start it out like in the box, you know that the carbon is bonded to 2 of the oxygens and 1 hydrogen. The other hydrogen has to be bonded to 1 of the oxygens, okay? So when you do it this way and then you fill in the lone pairs, that gives us to 18 dots, 2, 4, 6, 8, 10, 12, 14, 16, 18 dots. But I need, that's all I'm allowed, but the carbon's not satisfied the octet rule. So again, you could go double bond. In here, I'm showing you why this is the better structure in terms of formal charge. But this right here is the same exact structure as this, just kind of written with a different orientation in space. And then on the actual quiz key, I drew it with a little bit better in terms of the shape, right? So trigonal planar around the carbon here, bent around this oxygen, okay? But based on the clues, we should be able to come up with this structure here, okay? And then maybe answer some questions about it. So trigonal planar, bent, sp2, sp2, sp3 hybridized. So just the different things like that. All right, so hopefully this helps you out with prepping for the model kit lab quiz. It's, as you know, if you think this is easy, it's because it's not difficult. It just, you gotta memorize some things, but it's all pretty simple and straightforward. Just don't fall for the traps, right? This bond angle is not really 180 degrees, okay? So that should be good. Hopefully you found this helpful. Good luck on the quiz. All right, have a great day.